All right, everybody, welcome back. I'm so excited for this deep dive because we're talking about something that sounds like it's straight out of science fiction.
It kind of is.
Yeah, like we're diving into DeepSORT today.
Oh, yeah.
This is the tech that makes computers understand movement in a whole new way. Like it's almost like giving them eyes, but not just eyes, like a brain that can actually follow objects and predict where they're going.
Yeah. You know how impressive it is to watch a pro basketball player weave through defenders?
Oh, totally.
DeepSORT can track that ball as it's passed from player to player, even when it goes out of sight.
No way.
Yeah, it's like the computer knows what's going on, even when we can't see it.
That's wild. Okay, I have to admit, before we started prepping for this, I didn't really get what the big deal was about object tracking.
Oh, I see.
Like, I knew it was important for things like self-driving cars,
Right.
but I didn't really connect the dots.
Well, think about it this way. Those cars need to know exactly where everything is around them. Pedestrians, other cars, even like those little scooters that zip around.
Oh, yeah, those things are everywhere.
And they need to track these objects in real time to make decisions like when to brake, when to change lanes, even when to honk the horn.
Okay, now that you say it like that,
Yeah.
that makes a lot more sense.
Right.
So we're not just talking about seeing an object, we're talking about understanding its movement.
Exactly. It's the difference between just taking a picture and actually filming a video.
Oh, okay, I get it. So how does DeepSORT actually pull this off?
It all starts with an algorithm called SORT.
Sort.
Yeah, it stands for Simple Online and Real-Time Tracking.
Okay, simple,
Yeah, well, it's all relative.
I bet.
But SORT uses this really cool thing called a Kalman filter.
Kalman filter, that sounds kind of complicated.
It is, but think of it like a prediction engine for movement.
Okay.
Imagine you throw a ball in the air. The Kalman filter can predict where that ball will land based on its speed and direction.
So even if something goes out of sight for a second, the Kalman filter can guess where it'll reappear.
Exactly. That's what makes SORT so powerful for real-time tracking.
But DeepSORT takes things even further, right?
Oh, yeah, that's where the deep comes in.
Uh-huh. Okay, so where does the deep come in?
Well, DeepSORT adds deep learning into the mix,
Deep learning.
which is a type of AI that can actually learn what objects look like.
Wait a minute, so it's not just about movement anymore.
Right.
It's about recognizing the objects themselves.
You got it. It's like giving the computer a photographic memory for shapes, colors, patterns, you name it.
So like if we go back to the basketball example,
Mm-hmm.
DeepSORT can tell the difference between LeBron James and, say, a referee, even if they're wearing similar jerseys.
Exactly. It analyzes each object and creates a unique set of features, kind of like a fingerprint.
Okay, that makes sense. So how does it use this information to keep track of everything?
Well, that's where those terms you mentioned earlier come in.
Mahalanobis distance and cosine distance.
Yep. Those are mathematical ways of measuring how similar two objects are based on both their movement and their appearance.
Okay. I remember seeing those in the research, but I wasn't really sure what they meant.
Well, the Mahalanobis distance takes into account the uncertainty of the object's position.
Because things aren't always moving in a perfectly straight line.
Exactly. And the cosine distance measures how similar the appearance features of two objects are.
So the lower the distance, the more likely it is that they're the same object.
Right. It's like a double check to make sure that DeepSORT is making the right connections.
So is that how DeepSORT solves what you call the assignment problem?
Exactly. Remember all those players running around on the court? The algorithm has to figure out which detection in each frame belongs to which player, and sometimes there are multiple possibilities.
Right. So it's not just randomly connecting the dots. There's like some serious math happening behind the scenes.
Oh, absolutely. And to make sure it's making the best possible matches, DeepSORT uses something called the Hungarian algorithm.
Okay. Another algorithm. What does this one do?
It's a classic technique for solving what are called optimization problems.
Optimization problem.
Like finding the best way to match things up based on certain criteria. It's been used in all sorts of fields, from assigning tasks to workers to, well, tracking basketball players.
So the Hungarian algorithm helps DeepSORT make sure that it's assigning the right ID to each object, even when things get chaotic.
Precisely. This is one of the reasons why DeepSORT is so much better at handling occlusions than other tracking algorithms.
Occlusions.
That's when an object is partially hidden from view, like when a player passes behind a referee.
Right. So even if we can't see the whole object, DeepSORT can still keep track of it based on its appearance and its predicted movement.
Exactly. It's like the algorithm has a little bit of ESP. It can kind of see through obstacles.
Amazing. You mentioned earlier that DeepSORT has a ton of potential applications beyond just sports.
Oh yeah, the possibilities are endless. We already talked about self-driving cars, but think about analyzing traffic patterns in a city.
Oh, that's a good one.
DeepSORT can help identify bottlenecks, optimize traffic light timing, maybe even predict accidents before they happen.
Wow, that's incredible. I bet it could also revolutionize sports analytics. Imagine being able to track every player's movement on the field, see how they interact, and identify patterns that lead to wins.
Coaches would go crazy for that data, and it's not just about professional sports. DeepSORT could be used to analyze amateur games, helping players improve their technique and strategy. It could even be used to create personalized training programs.
That would be so cool. It's like taking the guesswork out of coaching. You can actually see what's working and what's not.
Exactly. DeepSORT allows us to see the game in a whole new light.
It really makes you wonder what other insights are hidden in the data that we just haven't been able to unlock yet.
That's a great question. As deep learning and computer vision continue to evolve, I think we're just scratching the surface of what's possible with DeepSORT and similar technologies.
It's a little bit mind-blowing to think that computers can now see and understand movement in such a sophisticated way.
It is pretty remarkable, and it's just going to keep getting more impressive in the coming years.
Well, this deep dive has certainly given me a lot to think about. Who knew object tracking could be so fascinating? Thanks to everyone for joining us, and until next time, keep those minds curious.